So in this video I'm going to tell you about a very useful tool to help get your kids learning and enjoying chemistry. So the tool I'm going to talk about is the molecular model kit. So you can get they're called ball and stick models. So you have different coloured balls to represent different atoms, and you can join them together to make different molecules. The most kind of famous company making these is a British company called Molymod. So I'll show you that kit in a second, and I've also got an unbranded kit as well, which presumably is considerably cheaper, and I'll show you that kind of thing. So first of all, here's a typical molecule. The black balls represent carbon atoms, and the little white ones are hydrogen atoms. Typically the kits will have balls of the same size but different colours for different atoms, with the exception of hydrogen, which will be small, just to remind us that hydrogen is the smallest atom, and also to take up less room because in the box, because you're going to generally have loads of hydrogen atoms. So this molecule is Cyclo Butane. Butane means hydrocarbon with 4 carbon atoms, and cyclo just means it's in a ring. And the black carbon atoms have 4 holes in, 1, 2, 3, 4, because carbon can make 4 bonds, 4 covalent bonds. So that's bonds where they share electrons. Hydrogen only has 1 electron, so it's a proton with a single electron going around, and therefore it can only make a single covalent bond, because the first shell of electrons around the nucleus can take up to 2 electrons, and then the next one is 8. So carbon is atomic number 6, which means it has 6 protons, 6 electrons going around. So you've got 2 electrons in the first shell, 4 in the second. Second one, remember, can have up to 8. So that's why it's able to make 4 covalent bonds. So yeah, these kits are amazing, really, really fun to use. I had never heard of cyclobutane, but my son Edward just made this playing around and said, "Does this exist?" And I checked it on Google, and yeah, I googled for cyclobutane. I could guess the name would be cyclobutane because cyclo, if there's a ring, and bute is the prefix for 4, and ane is a hydrocarbon with no alcohol groups or whatever. So here's what the kit looks like. So this is one of the Molymod kits, and this is for organic chemistry. Try and hold it without everything falling out. So different 2 different connections. This is for a single covalent bond. This is also a single covalent bond, but because it's a bit flexible, you can have 2 or even 3 together to show a double bond. So there's a carbon atom, it's oxygen atoms, and you can connect them together like this. And put them onto your carbon atom to make CO2, carbon dioxide. So that would be, so CO is carbon monoxide, but I forget what the bonding between them is. Carbon monoxide is obviously deadly poisonous. But here we have CO2. Get the connections in. And, yep, there we go. This is this obvious a model. These model only one aspect of molecules, which is the covalent bonding. Obviously molecules have, well, obviously, but yeah, molecules have other types of bonding like ionic bonding, hydrogen bonding, that kind of thing. So Van der Waals bonding. But anyway, most of the kits use the Molymod colour scheme. So black is carbon dioxide, red is oxygen, small white one is hydrogen, blue is nitrogen, and green is chlorine. So for example, chlorine can make a single covalent bond, nitrogen 3 covalent bonds, oxygen 2 covalent bonds. And this oxygen is atomic number 8. So that means 2 electrons in the first shell, 6 in the second. The second can have up to 8, so it can have 2 more, make 2 more covalent bonds. So even, with a little kit like this, you can make a really, really wide range of molecules. Now this is an organic kit, so you're mainly dealing with carbon, hydrogen, oxygen. And this kit comes with a little instruction booklet that explains the system and shows you loads of example molecules you can make. I don't know why that's come out of focus, but I should be able to read it. An apple in the Chromie camera. So you can make famous things like acetone, which is nail polish remover. What's another good one? Methanol. Methanol. Methanol as well. Yeah, so that's an example of that kit. Here is a completely unbranded, presumably cheap Chinese copy. This one's very similar. So it's using the same colour scheme. The balls are almost identical to the Molymod ones. Tiny, the holes are a tiny bit bigger. The bonds are similar. This one, interestingly, has these tiny little bonds as well, which are really nice for taking up the space. And so there's a carbon atom, and I'm going to stick some hydrogen atoms on to make CH4, which is methane. And it's very boring watching someone play with a model. I remember one of the early reviews of the first Tomb Raider game said, "This game is so boring, it's like watching someone play a computer game." So that's methane, CH4. And we could add on another carbon atom. And more hydrogen atoms. And we would eventually get ethane. So methane is 1 carbon, 4 hydrogens, and this is, so methane is ethane. If you had 3, that would be propane, 4 butane, That's 5. Let's forget 5. Pentane, obviously. 6 hexane, 7 heptane, I guess. 8 octane, 9, I have no idea. 10 decane. So, yeah, you can make these lovely models. So that CH3, that's not a molecule, that's a group, so it's a methyl group, 6 onto other things. Yeah, these kits are just fantastic, really, really fun, really worth getting, not that expensive at all. It's just so much fun stuff you can do. So one really good thing is just get your kids to make up molecules and then Google for them to find out about them. Look on Google, but also look on YouTube to see if there's any demonstrations of the properties of the molecules. I really wish I'd had a kit like this when I was first learning chemistry at school. I don't ever remember us playing with these kits at school, which is ridiculous, really, if you think how cheap they are, just a few bits of plastic. Yeah, it's just a kind of an example of it's kind of a simple educational toy, I guess. Although these are definitely made for school and even kind of university as a teaching aid, but as a toy, it's just fantastic because you can. My son put some atoms together. I didn't recognise what it was. I googled the formula, and he had made acetylene, which is the gas in cutting torches. One of them. Well, acetylene, of course, oxygen to make oxyacetylene, which burns at a very high temperature and will cut through thick plate steel. So yeah, really, really fun thing to play around with. And one of the things that you kind of learn in a very like passive kind of way you learn through osmosis is just with a handful of different types of atoms, the incredible combinations of things you can make. Very, very, very quickly, I will just explain. For example, if you have carbon atoms, 6 of them, and you make a ring with alternating between double bonds and single bonds. So this is going to take ages. I should have prepared one before I started this video, but just bear with me, please. I won't put the hydrogens on. I will just show you the ring. So we've got 6 carbon atoms. Now you'd think that would be called cyclohexane, but it's so important it has another name, which is the benzene ring. And compounds containing the benzene ring are called aromatic compounds, because the first ones discovered were kind of oily, sweet-smelling things. I'm pretty sure most of them are poisonous, so not something you'd want to spend a lot of time smelling. But that is 1, 2, 3, 4, 5, 6 carbon atoms, single bond, double bond, single bond, double bond. There should be a hydrogen atom on each one, and that would be benzene. And the benzene ring is massively, massively, massively important in life and nature and existence. And you just make it once with your child and they'll remember it forever. I think the benzene ring is an example of one of those things in chemistry which came to someone in a dream. It was known that benzene must have 6 carbon atoms. It was known through kind of analysis of the weight, but this was before electron microscopes, so it wasn't possible to know the structure, and I think a chemist kind of dreamt it, just like chemists dreamt the backbiting which you get in hydrocarbons. So when you have long chains of hydrocarbons and the end kind of connects back onto itself, allegedly some industrial chemist had a dream of a snake biting its own tail, and later this was confirmed by electron microscopes, I think. So yeah, that's just one example of, make a benzene ring and put if you put methyl group on, that would be toluene, I believe so. Now, one kind of limitation I'll point out is these kits can only do covalent bonds, electron sharing bonds. So, for example, if we wanted to make TNT, which is trinitrotoluene, so that would be, I think it's the benzene ring. If you imagine a methyl group on there, I'll actually put one on. So I'm not going to put on the hydrogens because it takes too long, but if you can imagine, you've got benzene ring, and then this would be a methyl group, so carbon with 3 hydrogens on. And the trinitro bit is 3 for tri, NO2 groups. Now, NO2, that's connecting to the benzene ring by ionic bonds. So that's, ionic bond is where atoms gain or lose electrons to become ions. So that's different to these covalent bonds where they're sharing electrons. So that's kind of one limitation, is that you can't, at least with the kits I've seen, you can't generally do other types of bonding. So, for example, it's a sulfur atom, and you can see it's only got 2 holes, because sulfur generally makes 2 covalent bonds. But in many, many, many important molecules, sulfur is making 6 bonds. H2SO4, sulfuric acid, stomach acid, H2SO4, it's an example of where sulfur is making 6 bonds. So that's kind of one limitation. I'll look around at other kits. So for example, I have definitely come across a kit on the internet, just the same, but the sulfur's got 6 holes in instead of the regular 2. So yeah, that's something to bear in mind. But generally, these kits are just an example of something really, really simple in kind of construction and use, and yet massively, massively, massively powerful. Massively powerful in that very, very fun to play around with. You can just get any basic book on chemistry and sit there with a kit making the molecules out of the book. Now that we have this amazing resources of both Google and YouTube and Wikipedia as well, you can just randomly stick some atoms together, make sure all the holes have got something in, and then Google that formula, see what you find. Certain concepts are just so easy to understand, so I know this video is kind of dragging on, but one really important thing in chemistry is the concept of isomers. So isomers are where atoms are the same number of atoms are kind of arranged in different ways. So if you imagine butane, which is 4 carbons in a line, populated with the hydrogens that I'm not going to put on. And then, so if this was covered in hydrogens, then that would be butane. If one of the hydrogens was replaced with an oxygen with a hydrogen on, like that would be butanol, like ol for alkyl group. But there are 2 possible positions for this alkyl group. It could go on the end. Now, if it went on the other end, that's exactly the same thing, flipped round, okay? However, it could go on the carbon atom 1 from the end. Now, if it went on either one, those are reflections of the same thing. And that's really, really easy to understand when you physically have the model in your hand and can flip it around. It's quite hard to understand just with pen and paper, to understand that there are only 2 isomers, not 4, for example, right? Because you might think 1, 2, 3, 4. No, but it's actually 1, 2. This one are reflections of the first 2. So isomorphism, maybe it's called. That concept that's really important in chemistry, super, super easy to understand with this kind of thing. Hope this video has been useful to you. I'm trying to raise money for treatment of my terminal cancer, so would really appreciate it if you can go to www.matthewdons.org, that's mathewdons.org, and either make a donation if you can, or share that page. Appreciate it so much. Thanks for listening.